One last thing about box plots. Box plots can be a good way to compare two different sets of data. Rather than comparing two big groups of numbers, it's easier to compare the summary or the pictures. So if we look at this, we have first period test scores and second period test scores. Which class had a higher median? Well, in math, we don't often get very many it's right there questions, so we don't have to calculate or think about too hard, but this is one. Which class had a higher median? Well, here's the median and here's the median, so it's pretty obvious that second period had a higher median. Which class had a bigger spread or variability? Now this one, for these two, you can pretty much just see which one is spread out, which one is longer. First period is more spread out than second period, so it has a greater variability. If you weren't sure if they were close, you could calculate the range for each one and see which one had the bigger range. But I think everybody can look at this and see that first period has a bigger range than second period. Which class had the higher upper quartile? This is another one that you can just look at. Here's the upper quartile for first period, and here's the upper quartile for second period. It's close, but still pretty obvious that second period had the higher upper quartile. Which class was most consistent? You might need to think about what consistent means. Consistent means more the same, doesn't change much. So it's the opposite of which one has the bigger spread or variability. This is which has the least spread, so that would be second period. Let's look at one more set of comparing box plots. Here we've got boys' height and girls' height. And we've got 9 statements. Which are true and why? So the first statement says the girls are taller on average. Well, if we look at the median of the girls and we look at the median of the boys, is that true? No, it's not true. Number 2, the boys are taller on average. Well, we just said yes, the boys have a higher median, so that is true. Number 3, the girls show less spread in height. Well, these are pretty close, so you might have to actually figure out the range, because this one starts a little before this one and this one ends after, but the difference here is pretty small. The difference here is bigger, so the girls do have less spread in height. Well, if that's true, then number 4 has to be false. The boys show less spread. The boys are more spread out, so that's not true. Number 5, the shortest person is a girl. Well, the shortest person is right here, and yes, that's on the girls, so that is true. Number 6, the tallest person is a boy. Well, the tallest person would be right here, and that is a boy, so that's true. Number 7, both data sets are skewed to the left. Now we've talked about skewed with dot plots and histograms, but not with box plots. But the whisker is like a tail. So you can see more of the data, the boxes, are more to the right, and the tails on the left are longer, so that is true. They are both skewed to the left. Number 8, half the boys are over 172 centimeters tall. Well, if you come to 172, yes, about half the boys are over 172. Number 9, half the girls are under 165. Well, 165 is right here. And so, yes, about half the girls are under 165. So most of those ended up being true. So hopefully that gives you an idea on how to use two box and whisker plots to compare two different sets of data.